Okay, students, this is lesson 6-6, trapezoids and kites. Just before we begin with this lesson, there are a couple of things that I'm going to let you know. I am going to assume, or I'm going to start with the understanding that you know lesson 1-2, which is the distance formula, that you know lesson 3-3, which is the slope formula, that you know lesson 8-3, which are the special triangles 30, 60, 90, and 45, 45, 90, and you know lesson 6-1, that was the lesson that we talk about what are the inside angles of any polygon. So knowing that we have covered all of those four, we are going to start 6-6 and trapezoids and kites. So for this one, we're gonna do a little bit of reading here before we begin. And so here we are, and it says properties of trapezoid. A trapezoid is a quadrilateral. That means when you add all the inside angles, it's going to be 360 with exactly one pair of parallel sides. So, and then the mid segment or median of a trapezoid is the segment that connects the midpoint of the legs of the trapezoid. So there's going to be two sides are going to be parallel. And if you have another line right here and goes from the midpoint to the midpoint of the legs, that is going to be the median. And the measure of the median is going to be 1/2 the sum of the lengths of the bases. In other words, the measurement of this median, to get this measurement, is going to be half of whatever the sum is of the top base and the bottom base. That's what it says there. If the legs are congruent, then the trapezoid is an isosceles trapezoid. So if this leg and that other leg are congruent, you have those markings saying that these are congruent. So it's going to be an isosceles trapezoid. And when you have an isosceles trapezoid, the base angles are going to be congruent as well. Okay, if legs are congruent, then the trapezoid is an isosceles trapezoid. In an isosceles trapezoid, both pairs of base angles are congruent and the diagonals are congruent. So that means this, let me go like this. This angle and that other angle are going to be congruent, and this one and that other one is going to be congruent, but also the diagonals are going to be congruent as well. Okay, the diagonals are going to be congruent as well. So basically that's what it's saying, and it's for a isosceles trapezoid. Okay, and that's basically what it says up there. And then here is the thing that I'm going to assume that you know. You know how to calculate slope. Okay, you know how to calculate slope. This is lessons 3-3, and basically to calculate slope, you need to go from point to point calculating the slope. You also know how to calculate distance, and this is lesson 1-2. So please understand a couple of things. There's going to be 4 lines. It's a quadrilateral, so it has 4 lines. It has a line that goes from A to B. It has another line that goes from B to C. Then a third line that goes from C to D, and then there's a fourth line that goes from D all the way to A. You need to calculate the slope for each one of them. Okay, for each one of them. So for example, AB, you calculate the slope for AB. Then you need to calculate the slope for BC. Then you need to calculate the slope for CD. And you need to calculate the slope from A to D. Now when you do that, you are looking, and what you're looking for is you need to find congruent slopes. When you have congruent slope, you have parallel lines. So now you know that AD is going to be parallel to BC. If those are the ones that are parallel, then you need to figure out if it's an isosceles trapezoid. So now what you're going to do is you are going to find the distance from A to B. Okay? You're going to find the distance from A to B, and that's what you're going to do over here. And then you need to find the distance. Let me go like this. You need to find the distance from A to B. That's what you're going to do here. And you need to find the distance from C to D over here. If by any chance you end up having congruent distances on the two segments that are not parallel, then you have an isosceles trapezoid. That's basically it. So here we go over a couple of examples. I'm going to explain something in this sample. Okay, and they're asking me what is the measurement of D. Well, let's begin by understanding that I have congruent legs. If I have congruent leg, I have congruent angles. So that means that B is 125 degrees also. Okay, so now I'm supposed to be able to go to the calculator and say, well, if it's a quadrilateral, I have 360 degrees. Okay, minus 125 minus 125, that equals 110 degrees unaccounted for. Well, that 110 degrees unaccounted for, I have to split them evenly between C and D because those are congruent, so I'm going to divide this by 2. And that equals 55. So C is 55 and D is 55. Now I want you to notice something here. And what I want you to notice is, look at this, 55 and 125. 125 added to 55. That means A and C are supplementary, and B and D are also supplementary. Okay? So let's take a look at this other problem over here. Let's take a look. I see immediately, I see that these two legs are congruent. I also see that these two bases are parallel. If these two bases are parallel, that means that if the question is L, right here's the question, and I know K, I know that those two are going to be supplementary. So I take 180 and I'm going to subtract 40, and that gives me 140 degrees. And just like that, we were able to do those two problems. Now the next one is going to be a little bit more trickier. And for the next one, I'm going to assume, like I said, I'm going to assume that you know how to calculate the slope, and I'm going to assume that you know how to calculate the distance. Coordinate geometry. For each quadrilateral with given vertices, verify that the equilateral is a trapezoid and determine whether the figure is an isosceles trapezoid. Okay, so now to determine whether this trapezoid, problem number 3, if this trapezoid is an isosceles trapezoid, and number 1, if it's a trapezoid, I need to find two sides that are parallel. And then the two sides that are not parallel, I need to check if they are congruent. That means if they have the same distance. So to begin, I need to check this line from A to B. And from A to B, I'm going to find the slope. So I'm going to do y2 minus y1 over x2 minus x1. So this is a 2 minus 1 and a 3 plus 1. This is a 1 over 4. That's from A to B. I'm going to do from B to C. From B to C, again, y2, negative 2, minus y1, 2, x2, 1, x1, 3. So this is going to be a negative 4 over a negative 2. Negative over negative is a positive. 4 divided by 2, it's 2. So that is the slope from B to C. And now let's find the slope from C to D. Slope from C to D, I start with y2 is going to be negative 1, y1 negative 2, x2 negative 1, x1 1. So on this one I have a 1 plus 2 over a negative 2 minus 1. This is a 3 over 4. No, sorry, a 3 over negative 3. And this is a negative 1 as the slope. And finally, I need the slope from A all the way to D. Again, y1 negative 1, y2 1, x2 negative 2, x1 negative 1, negative 2, negative 2 plus 1. This equals a negative 2 over a negative 1, and this also equals 2. Now notice please that I have two let me go like this. I have two slopes that are congruent. So the blue slope and the orange slope are congruent. So now what I need to do is I need to find the distance from, I need to find the distance. So the blue and the orange are congruent. So I need the distance of green and pink. Those are the distances that I need. So for the distances in pink or in green, I need to know that the distance, let me go in, the distance is going to be the difference of the x squares added to the distances of the y squares, of the difference of the y squares. So for this one, I can easily say, okay, so it's a negative 1 minus 3 and 1 minus 2. That's for the green. And then for the pink, I can say that it's going to be for the pink is going to be 1 minus negative 2, and then it's going to be negative 2 minus negative 1. Okay, and then the green is going to give you the slope of AB, which is going to be square root of 17, and the pink is going to give you the square root of 10. This is a 10. So now looking at this, I see that those two are not congruent. Therefore, this trapezoid, it is a trapezoid. It is a trapezoid because I found two sides that are parallel, but it's not an isosceles trapezoid because the two that were not parallel are not congruent. Therefore, problem number 3, I can say it's a trapezoid, but it's not isosceles because the distances of the legs is not congruent. Now problem number 5. So it's telling me for the trapezoid J, K, L, M, and N are midpoints of the legs. Okay, so those are the midpoints of the leg, and they want to find the measurement of MN. Okay, they want to find the measurement of MN, and that's I'm talking about this problem over here. So I know HJ is 32. I know that KLK is 60. All I need to do is add those two together. And divide by 2. Okay? And that is going to give me the distance from M to N. And that distance is 46. Now on the other one, might be a little bit trickier because you see on this one, HJ is 18. Okay? MN is 28. Okay? So they want to know the distance of LK. Here's the question this time. What is LK? So I'm gonna set it up exactly the same way. I'm gonna say 28 over here. I'm gonna divide by 2, and I'm gonna say 18 added to a number is gonna give me 28. I'm gonna do a little bit of algebra, which you know how to solve algebra, okay? And basically the question mark is a 38. And that's it for problem number 6. Now what happened with kites? On a kite, properties of a kite. A kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. Okay? And basically what it says is this side is going to be congruent to that one, and this side is going to be congruent to that other one. Okay, 2 pairs of consecutive congruent sides. Unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. The diagonals of a kite are perpendicular. So that means the diagonals, these 2 diagonals over here is going to be perpendicular. So I have a 90-degree angle here, 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 okay? So I have a 90-degree angle right there. Okay? In a kite, exactly 1 pair of opposite angles is congruent. So what it's telling me is that this angle right here, the whole M, is going to be congruent to the whole P. Okay? So those 2 angles are congruent. Okay? And that's basically, those are the properties of the kite. If we start doing a little bit of problems over here, it's gonna be quite easier. Let's start with this problem. Find JRK. So JRK, that is the diagonal right here. Okay, the intersection. So that is simply 90 degrees. 90 degrees on that one. Okay. The next one is, if RJ is 3, RJ, this one is 3, on RK it's 10, find JK. So here's the question right there. Well, I have a 90-degree angle right here. So to find that all I need to do is apply a little bit of Pythagorean theorem, and it's going to be 3 squared added to 10 squared, and this is going to give me 109, square root of 109. That's it for that problem. For the next one, GHJ is 90, GHJ, ooh, that whole thing over here is 90 for this point in particular. GKJ, this one down here is 110. Find HGK. Okay, so let's see. it's telling me that over here I have a 90, but down here I have 110. Now if I add those two together, it's gonna be 200 degrees. Now the 200 degrees, please understand, that are in a quadrilateral. Are in a quadrilateral right here. And this quadrilateral has 360 degrees. So you load your calculator, you say, okay, I have 360 degrees that the quadrilateral should have, out of which I already know 200 degrees. That gives me 160 degrees unaccounted for. Now I know that these two are exactly the same. These two are congruent. So I'm going to take that 160 degrees and I'm going to split it evenly between those two. And it's going to give me 80 degrees for G and J. 80 degrees for G and J. Problem number 4, HJ. It's 7. Let me select another color over here. HJ. It's 7. Right here I have a 7. Okay. And find HG. Oh, well, those two are needs to be congruent. So that is also 7. Boom. I'm done with that part. Easy and peasy. Change the color. Let me go to GH is 7. GH is 7. GR is 5. GR is 5. Find HR. Well, I see that I have a quadrilateral. I have a 90 or a right triangle here. I have the hypotenuse, a leg, and then I'm missing the other leg. So for that one, I need to say that HR will be 7 squared, that's the square root of 7 squared minus 5 squared. And you put that in the calculator, and I'm pretty sure it's gonna be 2 square root of 6. And finally, the last one, GHJ, that means that one again, but this time it's assuming that it has a 52-degree angle. HG, GKJ, is 95. So this problem, you are going to do it exactly the same way that we did problem number 3. And for that one, you end up with 106.5. Okay. These are easy problems. The one that you need to pay the most attention to for today's assignments is going to be problem 3 and 4. I know that I only did 3, but number 4 is done exactly the same way. And now, do your Delta Math assignment.